Every time you generate an AI image or stream a movie in 4K, a digital pulse travels across the country into a massive data center. Inside those buildings are thousands of supercomputers. They run hot, and they demand hundreds of megawatts of electricity every second of every day. This creates a physical conflict. We want a green power grid, but solar panels stop producing when the sun sets, and wind turbines stop when the air is still. The internet, however, never shuts down. To bridge this gap, the largest technology companies in the world, Amazon, Google, and Microsoft, are all turning to a single source: nuclear power. To keep our AI models training and our servers running without heating the planet, we need a carbon-free engine that is completely immune to the weather. Pop culture often uses images of glowing green rods to explain nuclear energy, but in reality, a modern reactor is essentially a zero-carbon steam engine. It works through a two-step process. Inside a sealed core, splitting uranium atoms releases immense heat. That heat warms a closed loop of water kept under so much pressure that it cannot boil. This super hot water flows into a generator, where it passes its heat to a second, separate loop of water. That second loop boils into dry steam. Because these two loops are physically isolated, the radioactive water never touches the clean steam. Finally, that high-pressure steam rushes past a massive turbine. The steam spins the blades, which turns a generator to create electricity for the grid, all without releasing a single puff of smoke. Despite its complex reputation, a nuclear reactor is just a highly engineered way to boil water without burning fuel. Today, a tech company can build a giant data center in under 2 years, but actually getting permission to connect that building to the power grid can take 5 years or more. To bypass this wait, Microsoft is helping restart a famous retired plant in Pennsylvania, 3 Mile Island. They have signed a 20-year deal to buy all the electricity it produces once it comes back online. Amazon is taking a different route. They bought a data center campus built right next to an existing nuclear plant, allowing them to pull power directly from the source without using the public grid at all. Google is looking toward the future of the technology. They are funding a series of small modular reactors, compact plants that can be built in factories and quickly assembled on site. For these companies, restarting old reactors and building small new ones is the fastest way to get the massive amounts of carbon-free energy they need. Unlike wind or solar, nuclear reactors produce a physical, radioactive byproduct. It is a serious material, but because uranium is so energy-dense, the actual physical volume of waste produced over several decades is remarkably small. We also have a way to store it permanently. This is the Onkalo facility in Finland. It is a deep geological tomb carved into solid rock, designed to hold high-level waste forever. The waste is isolated using multiple barriers. Engineers seal it inside a cast iron core, wrap that core in a thick copper shell, and then pack the entire capsule in water-absorbing clay. These capsules are lowered into holes drilled into solid granite bedrock. This rock hasn't shifted in nearly 2 billion years, which ensures the material stays isolated from the surface for over 100,000 years. By treating waste as a manageable engineering task, the industry has moved from temporary storage toward a permanent physical solution. When you look at the entire lifespan of a power plant, from the mining of materials to the final decommissioning, nuclear energy actually has the lowest carbon footprint of any commercial source. This efficiency comes down to energy density. Because uranium is so concentrated, a nuclear plant requires far less land, steel, and concrete than a wind or solar farm of the same size. We can see the impact of these choices in Europe. When Germany shut down its reactors, it had to burn coal to fill the gap. Meanwhile, France utilized its nuclear fleet to maintain a reliable, low-carbon grid that doesn't depend on fossil fuels. As we build more advanced technology, our demand for power will only grow, but we can continue to innovate while protecting the planet, as long as we use the right tools for the job. If you enjoyed this breakdown, subscribe to Refreshing Tech for more clear, jargon-free looks at the modern world. Thanks for watching.